Hello everyone. Welcome back to data structures. So in this lesson, we will be learning about unions. Okay, so here you can see the definition of a union. Unlike structures, union is a collection of logically related heterogeneous data elements which shares a common memory. Let's see. Here you can see we have an integer, you have a character, you have a floating point value, and you have two strings A and B. Size of A is 10 bytes and size of B is 30. Okay. So here all these logically related elements, let us see that it is a student data. Okay. So these are all the values related to some specific student. So say, as usual, union is a user-defined data type similar to structure. And here it is containing different data types. And here the members in C union are stored in the same memory location. What does it mean? So here you can see, if you have idea of how much memory will be allocated to each data type, let's see how much memory will be allocated to this integer value. It is 4 bytes. For this float, another 4 bytes. And then for this integer, 1 byte. And then for this character array, 30 bytes. And for this character array, 10 bytes. Okay, so all these will share the same memory location. Which location will they share? So it is nothing but the largest value, okay, of the memory that is allocated to this union. So here, what is the size of the largest member? It is the array B. So here the size of this member is 30. So 30 bytes will be allocated to this, which becomes the size of the union. So that is what the meaning of the same memory location will be allocated to all the members. So here they will share this memory. So because of this, at a time we can access only few members, or in some cases only one member can be accessed at a time. So for example, if you see, first of all, if I'm accessing the value of this B, okay, so the memory that is allocated to this union is only 30 bytes, and all that 30 bytes I'm using. So then what about the other members? Can they store their values? Here you can see a 30 bytes of memory is allocated to this union. Okay. So now, so say suppose B has come and written some data. So it has used all the 30 bytes. Okay. So some value is written. So then can I read the value of this number? Yes, of course. So first these 30 bytes, say suppose I have written 20. Then now I want to write A. So then again this value will be overwritten by A, and then this will be overwritten by 33.33, and this will be overwritten by the value of this character string B, and then the value will be overwritten by this. Does it happen really? We will see with a small hands-on to verify this. And before doing that, we will just see the syntax and how to access the members of a union. We'll first see. So the definition is similar to a structure. So here we use a keyword called union. Union followed by union name, and inside we'll be specifying all the data members that we need. Data type 1 followed by member name 1, and then data type 2, member 2, and so on. You can give all the members of your choice and end it with a semicolon. The definition is very much similar to a structure. Let's see one example. I'm using the keyword union followed by the name of the union, which is shared data. And then I'm taking a character array, which is of size 10. And then I'm taking another variable now, which is of short int, and end it with a semicolon. So now can you tell me what is the memory requirement for this union? Or how much memory will be allocated to this? Okay, so if you see the first variable, char ch of 10. So how many bytes does it require? It requires 10 bytes. Then how many bytes will be required by this short it? 2 bytes. That is, so now according to the definition, the memory that will be allocated to the union is the size of the largest member. So what is the size of the largest member? That is 10 bytes. So this becomes the size of union. So that means if you declare one variable of this type union, the memory that will be assigned to that variable is 10 bytes. Say suppose if the same thing I'm treating as a structure. So in case of a structure, how much memory will be allocated to this? It is 10 plus 2, which is 12 bytes. So that is the sum of the memory required or memory allocated for all the members of this structure. So 10 bytes for CH and another 2 bytes for num, a total of 12 bytes. Okay. Hope you have understood the memory requirements in case of a structure and union. Let's verify the same with a small hands-on. So here I have just typed readily and I have kept it. Okay. Yeah. So here we have taken a student structure. The first one is character, which indicates the class of the student, and then section. So here class means first year, for F for first year, S for second year, T for third year, F for final year, and section, and then roll number. Okay. So now can you tell me how much memory will be allocated to this union? So first of all, if you see, char requires 1 byte of memory. Then again, for section also 1 byte is required, and roll number, which is of integer data type. So it takes 4 bytes. Okay. So now size of union is nothing but size of the largest member, which is 4 bytes. So this becomes the size of union. So that means if I declare a variable of this type union, so the memory that will be allocated to the union will be 4 bytes. Now let's compile and see. Yeah, it's successfully compiled, and we are using size of operator to know the size of it. I have declared a variable S1, which is of type union, and I'm printing the size of it. So the memory allocated for S1 is 4 bytes. That is what we have verified, right? The size of the largest member of the union, which is 4 bytes. So now let's talk about a structure and let's see how the memory will be allocated. Before going to that, let's try to read the variable values for class, section, and roll number. Yeah, here I have done the coding for you. So here we are reading the roll number. To access the member of a union, it is similar to how you access the member of a structure. So here I have declared a variable of type union student S1. So accessing its name of the union variable, which is S1 dot roll number. Similarly, S1 dot name, S1 dot section. In scanf, we use ampersand, as you know. And here for string, we need not use an ampersand. I'm using %ls. Here I have changed the members slightly just to show you the size requirements. So here I've taken a name which is of size 10 and char section 1 byte and roll number 4 bytes. Okay, what is the maximum size? 10, right? So that much size will be allocated to this structure. And the whatever values I'm reading, roll number, name, and section, the same thing I'm trying to display. Let's see, can we do this? Okay, so what we have learned, all the members will share the same memory location. Okay, So whatever values I am reading, that should be stored in the same memory location, and that should be accessed also from the same memory location. Let's run it. I'm compiling it. Now let me run this. Yeah. So memory allocated for this structure is 12 bytes. Okay, I will tell you the reason for this, why it is taking 12 instead of 10, or else I don't want to confuse you people. I'll just take the name size of the name as just 8 bytes, just sufficient for the CPU cycles. Yeah. So memory allocated for the structure is 8, which is the size of this string. And now let's enter values for roll number. So I'm entering some random number, roll number 12. So in place of class, I have renamed the variable as name. I will give my name. Okay. And then section. Okay. Let's give section as F or else capital A. Okay. So now let's see what will be the output. So usually if it is a structure program, it needs to display the roll number, it needs to display the name, and it needs to display the section also. But it is a union which is going to share the memory. So now let's see what will be the result. So here you can see the order in which I am printing is, first I am accessing the roll number. So that is the first value that I have read. But here, what is the value that it is displaying? Some garbage value it is displaying. And then name. Again, name also will use the same memory location. It also didn't store properly. And then section, that also will use the same memory location. I didn't get result for this at all. Okay, so this is the problem with union. So the problem with union is, since you are all the members are sharing the same memory location, only one member can access the memory location successfully at a time. Okay, let's see whether that will be done or not. I'll just comment out the other two scanfs. I'll just read one by one variable and try to print whether will it be done properly or not. So here you can see I'm reading only the roll number. I'm trying to print the same. Okay, whose size is 8, which is the size of the union. I didn't change the print statement, but what am I supposed to give? I need to give a name. I'm giving my name. So here you can see, I think I have not compiled. 1 second, let me compile this. If I won't compile, what will happen? The previous exe file only will run. Whatever obj file that is created earlier with the previous code will be there. The same thing will run. So because of that, we are not getting the result that we are expecting. So here the input that I am supplying, what am I supposed to give? Roll number. Okay, it's not name. Some roll number I should give. I'm giving a value 12. So here you can see it is displaying 12. Now let me change. Okay, I'm able to successfully access the member roll number. So this time I want to access the name. So I will comment out the rest of the thing and I'll only highlight the scanf and printf related to name. Okay, let us compile it again. Otherwise, the previous obj file gets accessed and the same thing will be run and it will generate the exe file. Now let's see the name. Let's give the input name. I've given my name. You can see the name it is displaying as Sriveni. This, and let's try to access the section as well. I'm giving section F. It is printing. Okay, so now since the size is 8, let me try to give the roll number as well as section. Let's try. What will be the result? Okay, roll number requires 4 bytes, section requires 1 more byte, a total of 5. Okay, which is less than the size of the union. Let's see whether we get these two values successfully or not. Okay, I have entered roll number. Then I have entered section A. See, I didn't get. So, hope you have clearly understood how the memory requirements will be there in case of a union and a union, that all the members will share the same memory location. Since all are sharing the same memory location, only one member can be accessed successfully at a time. Now let's replace this with the structure. I just want to show you what is the memory required for a structure. Because I have not done this when I have done with the structures, I guess. So I just want to show you. Rest of the code I'll just comment out. I just want to show you the size, that's all. I'm using the size of operator on S1, which is a variable of type struct student. Okay, so what is the memory that will be allocated? The size of this name array, which is 8 bytes. Then for section, one more byte, 9. And for roll number, another 4. Okay, 8 plus 1, 9, 9 plus 4, 13 bytes. It is giving us 16 bytes. Why? Instead of 13, why am I getting 16 bytes now? I will just increase. Otherwise, I will take only two variables, name and roll number. Now it is giving me 12 bytes. 8 bytes for name and for roll number another 4. 4 plus 8, 12. But what's happening? If I add one more odd number, okay. So now the size is 8 plus 4, 12, 12 plus 1, 13. But it is giving me 16. Always a multiple of 4 it is giving me. Why it's happening? Okay. So this is due to the padding that is being added. Okay. Let's discuss about the padding and packing in the next session. Hope you have followed, if you have clearly understood. But theoretically, we will say the memory required for this structure is 13 bytes only. Okay, how do we get that is, you can just add this pragma command here. Okay, so it is a preprocessor directive, hash pragma pack1. That means I don't want the memory to be multiple of 4. Yeah. So now you are getting the exact requirement. The theory, whatever we have read, that is not wrong. It is correct only. Okay. The memory required for structure is 13 byte. But why execution wise it is showing me differently. Okay. For the first year students who are preparing for the theory exams, for you this much is enough. The size required for a structure is only 13 bytes. The size required for a union is 8 bytes. Okay. But those who are preparing for other competitive exams or those who need extra information can follow the next lecture, which is on packing and padding in structures. Hope you followed. If you have any queries, let me know in the comment section. And one more thing is, do watch the complete video. If you skip certain part of the video, you won't be able to follow. Okay. Thank you.